Hey everyone, this is our Chapter 2 statistics test. We're in the home stretch here. We're looking at questions 10 and 11. So let's have a look over there. 10% of all narwhal tusks fall between 95% of all narwhal tusks fall between 1.2 and 2.8 meters in length. And if narwhal tusks follow a normal distribution, what is the mean and standard deviation? So I've gone ahead and laid out my normal curve, and I see 95%. And immediately that should trigger my brain the empirical rule, because 95% is associated with 2 standard deviations. So I know within 2 standard deviations, that's going to be 1.2 meters and 2.8 meters. Again, the only reason I know that is because I've memorized that 68, 95, 99.7 rule. So you really need to memorize that to get through these with a lot of efficiency. Now, how do I find the mean? Well, the mean should be exactly in the middle of 1.2 and 2.8. So let's just find the average here. So the mean should be equal to 1.2 plus 2.8 divided by 2. And what do we get? We got 4 divided by 2. Well, that's just 2. So the mean here is 2. Now, to get to the standard deviation, it's probably easier if I go to the positive side, and these are equally spaced standard deviations. So from 2 to 2.8 is 2 standard deviations. So 2.8 minus 2 divided by 2, that's going to be 2 standard deviations. So that's 0.8 is equal to 2 standard deviations. So a standard deviation should be equal to 0.4. And try it out. 2 plus 0.4 is 2.4. 2.4 plus another 0.4 is 2.8. Seems to work. Let's go in the opposite direction. 2 minus 0.4 is 1.6. 1.6 minus 0.4 is 1.2. So again, that seems to work out. And we have a normal distribution with a mean of 2 and a standard deviation of 0.4. Writing this out, you get that the narwhal tusks have a mean of 2 and a standard deviation of 0.4. Let's take a look at number 10. We've got the best male long jumpers for the state college since '73 have average of 263 and a standard deviation of 14. Then it goes on to give us the same information for the female long jumpers, which have an average of 201.2 and a standard deviation of 7.7. This year, Joey jumps 275 inches and his sister Carla jumps 207 inches. Both are state college students, and since the male and female jumps are normally distributed within their groups, which athlete had a more impressive performance? So when we say within the groups, what we're looking for is greatest z-score. Because z-scores allow us to normalize, to compare between 2 different groups, as long as the groups are, no, actually they don't even have to be normally distributed. They can be compared within their groups, which one is more exceptional in terms of the mean long jump in this case. So we've got our first curve, and I'm going to label this for the male long jumpers. So here are the male long jumps, and I'm only going to label the part of the normal curve which is important to us, which would be where does 275 line up? Well, 275 is just shy of 1 standard deviation. So I'll go ahead and I'll exaggerate that just a little bit here and put my 275 right there. And I have an unknown z-score, so I don't know the z-score. I'll go ahead and color code that yellow. We'll figure out that z-score in a minute. Let's move on to the females. Just like with the males, I'm going to only include the parts or the z-scores or the long jump lengths that are important to us, and those would be the ones that are greater than 201. So we notice that 207 right over here is also an unknown z-score, but it's also somewhere between 0 and 1. So they're pretty close, it looks like. Let's go down to our z-scores. Here we've gone and we've written our z-score formulas. Here's the one for Joey. Notice I just wrote the word Joey down there so that no one is confused about what that z-score is standing for. And here's the one for Carla, and just like before, I've gone ahead and I've written the word Carla as a subscript to Z, so there's no confusion from anyone reading your paper. Now let's actually make these computations with our calculator. Okay, we get a z-score for Joey of 0.857 and a z-score with Carla of 0.753. We're going to take those and we're going to put them back into our z-curves. And according to our z-curves, it looks like Joey has a more impressive jump. He is further away from his mean, taking into account the standard deviation. So since Joey's z-score is greater than Carla's z-score, Joey's jump is more impressive when you compare it to his peers. So that's it for the questions 10 and 11, our narwhal and our long jumpers. And we have one more question left. Number 12 is a long one, so we'll see that in the next video.